Here's example 9 with trig identities. So if you want to copy this packet we've been using, check the video description. There's a link in there. You can click that link, open this up, print it out. So cotangent of theta times cosine of theta equals secant of pi over 2 minus theta plus sine of negative theta. Okay, so we'll go back to our general process here. From an earlier video, always start on one side, try to make it look like the other side, and usually start with the side with the more complicated expression. So the right-hand side is a little more complicated, even though here we're multiplying. We're not really multiplying anything over here, but here we have a pi over 2 minus theta, here's a negative theta. So it's a little more complicated here. Okay, and also, hopefully this jumps out at us, is maybe we can use the complementary angle theorem. So remember, okay, well let's just get started with this. So we're going to start with the right-hand side. So secant of pi over 2 minus theta, and then we have plus sine of negative theta. Okay, so a couple of different things going on here. So first, one of our steps was to use the basic identities in the table above as well as the complementary angle theorem if applicable. So we're actually going to do both of these things here. Okay, so complementary angle theorem applies to this here because it's pi over 2 minus theta. We talked about that in an earlier video a while back. And then here's sine of negative theta. So that's kind of hopefully jumps out at us as, okay, well I have a negative theta, so let me maybe try and use even odd identities. And we're going to use the fact that sine is an odd function here. Okay, okay, so secant of pi over 2 minus theta. So remember from the even and odd, or sorry, from the complementary angle theorem, secant of pi over 2 minus theta, the complementary angle theorem tells us that this is exactly equal to cosecant of just plain old theta. Okay, and that is a really nice simplification. That's great, really helpful for us. So we're just going to use this fact. So we talked about this in an earlier video and saw why that's true a little bit. So let's use that fact. Okay, so secant of pi over 2 minus theta is cosecant of theta. And then what do we have here? Plus sine of negative theta. Well, sine of negative theta is negative sine of theta. So we have plus negative sine of theta. Okay. Well, if you add a negative, that's the same thing as subtracting. So cosecant of theta minus sine of theta. Okay. Okay, now what do we do from here? Well, from here, let's, so here's a cosecant, here's a sine, so let's rewrite this in terms of just sine and cosine. So, okay, that's one of our steps to try. Okay, so rewrite expressions in terms of sines and cosines. So we eventually want to get to something with a cosine. Yeah, it also has a cotangent, but there's a cosine. So what we have is a cosecant and a sine. So let's maybe just rewrite everything with just sine and see what happens. So cosecant is 1 over sine of theta. And then we're still subtracting a sine of theta. Okay. Okay, so is that helping us at all? Well, it's not really obvious yet, but it's going to get us there eventually, maybe. We'll see. So what can we try next? Well, next, let's try getting a common denominator. Okay, so that's sort of related to one of our steps, right? So, well, related to a couple of our steps, I guess, but here, rewrite sums of differences of quotients as a single quotient, get a common denominator. So we did something like this in an earlier example, but remember sine of theta is the same thing as sine of theta over 1. So what we have here is one quotient minus technically another quotient. So let's get a common denominator. So what is the common denominator? Well, denominator 1 means nothing. Denominator sine of theta, that is, okay, well, by means nothing, what I mean is the 1 in the denominator doesn't affect anything for us. So we don't have to worry about that. But here, the denominator sine of theta, that's our only really, that's the only denominator we really have to worry about. So let's get our common denominator is sine of theta. So multiply this one by sine of theta on top and on bottom. So now what we have here is 1 over sine of theta minus sine of theta times sine of theta, that's sine squared of theta. And then on the bottom we have 1 times sine of theta, which is sine of theta. Okay, that's great. So now 1 over sine of theta minus sine squared of theta over sine of theta. We can squish that all together into one fraction, one quotient, and that's 1 minus sine squared of theta, all divided by sine of theta. Okay. Now where do we go from here? Well, from here we see, okay, here's a 1, here's a sine squared. Are those related somehow? Because on the bottom we just have a sine. There's not much we can do with that. Okay, so you might be maybe tempted to cancel the sine with the squared up here, but it's absolutely totally illegal to do that, not okay, because we have the 1 here. So if you're going to cancel things, you got to cancel things from every term. Okay, so on the top we have a 1 and a sine squared. So if you want to cancel things, you got to have, it has to appear here, and in this term and down here. Okay, but the sign only appears here and here, not here, because this is just a 1, so we can't cancel anything like that. Okay, so be very, very careful about that. Very dangerous, very, very illegal. Be very careful with that. So let's go back here. Okay, so 1 and sine squared, how are those related? Well, here's a sine squared, here's a 1. Okay, so anytime you see a trig function squared, try to think about the Pythagorean identities and if you could use those in any way. So if you see a squared trig function, that's usually a hint to maybe use one of the Pythagorean identities because they involve squared trig functions. Anyway, if sine squared of theta plus cosine squared of theta is 1, so let's come over here off to the side. So sine squared of theta plus cosine squared of theta equals 1. So let's subtract sine squared from both sides. So then cosine squared of theta equals 1 minus sine squared of theta. Okay? And notice that's exactly what we have. Okay, 1 minus sine squared of theta. So that exactly equals cosine squared of theta. And we still have sine theta on the bottom. Okay? So we use this, I think, in example 8. One of the ways we did it, and we also used that in example 4, even though the functions were switched, but it doesn't matter. Anyway, why is it okay to do that? So you might be thinking, well, hey, aren't we just supposed to work on one side and try to make it look like the other side? Yeah, for the identity that we're establishing. Okay, we're establishing this identity here. Okay, so we just want to start on the right side, manipulate only that side, make it look like the left. Okay, so do not mix these two sides together. But it's okay to do that for this because this is a previously established identity. Okay, it's just an equation that we're using to help us establish this one. Okay, so for this previously established identity we already know is true, it's okay to manipulate this to our will to make it more useful to us. Okay, so we can manipulate this like this. Okay, so we can subtract something from both sides, but we cannot do that here. Okay, we cannot subtract anything from both sides here. Okay, we can only mess around with one side. Okay, so again, very important to keep that in mind. For the identity that you're establishing, only manipulate one side, and that's exactly what we're doing here. We started with this side, the right-hand side, and we're just messing just with that alone and leaving the left-hand side completely alone by itself. Okay, now we're almost there. So we're out of room here, so let's come back up here. So cosine squared of theta on top, sine theta on bottom. So that's the same thing as cosine of theta times cosine of theta, all divided by sine of theta. Okay, now this is the exact same thing as saying cosine of theta over sine of theta, and we can pull off this other cosine of theta, so it's the same thing as saying that. Okay? So remember, if you multiply by something on the top there, you can just pull it off the fraction and multiply it out off to the side. It's the exact same thing. Cosine of theta divided by sine of theta, that is cotangent of theta, right? So this is cotangent of theta times cosine of theta. And that's exactly what we wanted, cotangent of theta times cosine of theta. Okay, so that's that. Okay. Now in case you're wondering, well in this step I didn't really explain why I did that. So cosine squared of theta over sine of theta, we rewrite that like this, because there's really not much else to do. Okay, we used the Pythagorean identity here, we ended up with cosine squared of theta. Now here, there's really not a whole lot else we could do. Okay, it's already cosine and sine, so there's nothing to do with that. We can't rewrite in terms of sine and cosine because it already is sines and cosines. We don't want to use Pythagorean identities because we'll just undo what we just did. Okay, so cosine squared, that is cosine times cosine. So let's write it like that, see if anything jumps out. Well, hey, the thing that I want has a cosine in it, so let me pull that cosine off to the side. Okay, that's why I did that. And then what's left? Cosine over sine. Well, hey, that is cotangent. That's exactly what we wanted. That's great. Okay, so that's just how we kind of think about it with those steps there. Okay, anyway, check mark. We're good to go. That's example 9. Example 10 coming up next.